Good evening, everyone. Welcome to Tech Niche Sessions held by IEEE CS VID. I am Chinmayi Purohit, and today we'll be teaching you or revising the basic concepts of object oriented programming. We will be implementing some basic concepts of OOPS using C++. I hope you all have some knowledge and will be a quick revision with all of you about the same. Concepts we're going to look today are objects, classes, data abstraction, data encapsulation, inheritance, overloading, polymorphism, dynamic binding, and message passing. We'll be looking at each of the meanings, definitions, and syntaxes with a simple usage each. Let's begin. We will be implementing today's snip, OOPS with code snippets in C++. You can also do it in Java. Most basic thing of an object-oriented programming language is the object. These are the basic building blocks for designing programs. It may represent a person, place, data, or any other such things. It is a collection of data members and associated member functions. Each object should have a different name, and every object should belong to some class. Now, what is class? Class is a way of grouping objects having similar characteristics. Once a class is defined, you can create any number of objects with it. For example, a class is a blueprint, and with that, you can create n number of copies, which are the objects. Syntax here for the class is given. You use the keyword class and then use the class name. You can give whatever name you want for it. Here, the name I've given is my class. Then comes the curly braces, and then the data members, member functions. We'll learn what that is later. And then close the curly braces and do not forget to put the semicolon. Now, what are these data members and member functions? Members are batches of data that belong to the class, and member functions are functions that use the data belonging to the class, and these functions are also a part of the class. Tags for declaring object is you use the class name space the object name. Here you create an object of the class my class. For example, here the fruit is the class and it has data member, the color, and then the function void this. Here you take the input from the user, that is the color, and then you output the color in the sentence. The color of the fruit is whatever you get from the user. Now what is void, you would ask? Here the void is the return type of the function. You need to specify that for every member function. You can have integer return type, float return type, or even string return type, or char return type. Now, the void here means there's no return type to this function called display. Functions. Members of a class can be data or functions, as I already told you. There are private, protected, and public data types for each class. However, the private and protected can only be accessed by the member functions of the class. No function outside the class can access these data. The public data members can be accessed from any function, rather if it's a member function or not. And what is the syntax for accessing the class member from outside the function is you write the class object and member data. If it's a Public function, you write the class, object, member function, and then the arguments. Remember, private members are default by declaration. They are accessible only to member functions within a class only. Public members can be accessed inside as well as outside class definition. Member functions are also known as methods, and they act only on the data members of the class. Functions may be defined inside or outside the class. The scope resolution operator, which is two sets of colons, is used when a global variable exists with the same name as local variable. It can also when you're defining a member function outside the class. Or, as we have seen the syntax, class members are accessed using the dot operator. Class type elements is known as an array of objects. For example, if I create a class with, say, fruit as we saw in the previous example, I create an array of objects here. Functions can receive objects as function arguments. It is possible to pass objects to a function using pass by value or pass by reference. All the same as we have learned in OOPS the last semester. Now, there are some characteristics that member functions should follow. Number one is the type and number of arguments in each member function should be the same as type and number of data declared in the class definition. It means in the class definition, if you have three data members, then the functions in the class should have those arguments. You can use the same function name, but the membership level will resolve their scope. Member function can access private data of a class, and non-member function cannot. Let's have a quick revision about what we have learned till now. A class is a user-defined data that contains data members and objects. An object is an instance of a class. There are two types of members in a class. There are data members and member functions. Data members are different data variables, similar to structure members. Data members may be declared in a class as private, public, or protected. Look into these private, protected, and public data members in the further features of OOPS. Moving on to inheritance. Inheritance is the process of creating or taking down properties of one class to another class. And the class from where you take these properties is called the parent class, and the class where you're giving these properties is the child class. For example, here the syntax also is given. Let's see. This is the parent class, and the dog is a child class. If how do you call out inheritance? You define the animal class, and then you write class dog colon the access specifier, which is public, private, or protected, and then the class name from where you want to inherit properties. So it is basically the name of the class you want the properties to be inherited to, colon, access specifier, and the name of the class from which you want to take the properties. And same, the class definition as it is. Various types of inheritances. For example, single inheritance, multi-level inheritance, multiple inheritance, and hierarchical inheritance. In single inheritance, you have only one parent class and one child class. It's a simple example as given. Father to son. The son takes properties that belong to the father. In multiple inheritance, there are two parent classes, two or more parent classes, and one child class. So the child class will be having many parent classes. Now, the syntax for this can be the class name, colon, access specifier, class 1, comma, access specifier class 2, comma, access specifier class 3. Then the multi-level inheritance. Here, the child class of one parent class is the parent class of another child class. Basically, a class is a parent class and a child class to another class at the same time. For example, father is a child class to grandfather class, but it is also the parent class of the son class. And then the hierarchical inheritance. Here, there is one parent class and multiple child classes. For example, it can be a staff having one common head. Then there's another type of inheritance called the hybrid inheritance. In that inheritance, you can take whatever mixtures or combinations of these four inheritances. Remember, there are no rules to make inheritances, but make sure you have the right syntax and the right flowchart. Then comes data encapsulation. Now, within the word only, you have the meaning encapsulate. Here, it is the process of wrapping up data and methods into a single unit called class and controlling their access. So, this increases data security and prevents data from being accessed from outside the class. You can say sensitive data being controlled or accessed from outside the class. And as I had mentioned earlier, there are three access specifiers in C++: private, public, and protected. How do you declare what is private and what is public? Let's look at an example. Here, the bank account is a class, and within that, you have defined balance within private and the function deposit under public. You would ask, what is the difference between private and protected? Okay, protected. Whatever data members or functions you mention under protected, only the data members belonging to that class can access it, or the classes which are already inherited from that class. The child class, all the child classes can access the data present in the protected class. They can be accessible by any other methods. It has no boundaries or limits to who can access data in public. Private, only the class. Protected, the class and the child classes. Public, anybody. These are the three things and the differences between these three access specifiers. Comes polymorphism. Now, polymorphism can also be said as the ability of a message to be passed in multiple forms. Poly means multiple, morphism means forms. Let's look at an example where you see polymorphism. Now, here you have overriding and overloading. You would ask, what is overriding? In inheritance, if you overload a function, it becomes overriding. That is what I can put it as the best Example: you have already declared a function in the parent class and give it some definition. But in the child class, you take the same function and give it another definition. And when you create the object of the child class, only the function definition from the child class will be fulfilled. Here, for example, animal is the parent class, dog and cat are the child classes. As you can see, you have the bark sound and the meow sound within each of the functions. When you create an object of the dog class, you won't get the default sound. You will get the bark sound because the function make sound is being overridden by the child class. Similarly, when you create an object of the cat class, the meow sound will be heard and not the default sound. After overriding comes overloading. There are two types of overloadings. One is the operator overloading, and the other is function overloading. Let's look at operator overloading first. The plus symbol. Here, it can be used as an arithmetic operator for adding two numbers or integers or float. But it can also be used as a concatenation operator. It can be used to bring two strings together. Likewise, the two symbols I've mentioned, these are bitwise operators, shift left or shift right. But it can also be used for the cout and cin statements. Function overloading. Now, this is a very important aspect in OOPS because here you will have to, in programs which are complex, you have to have one function name but various number of arguments and different types of arguments that make your code more readable and easier. Here, the product is the function that is being overloaded. There is int and float return type of the product. Each of them have equally three types of arguments, but you can see the type of arguments are different. In the int product, there are three integer types of arguments and the output will be p into q into r. In product float, there are three arguments of float type and you will get x into y into z. So whenever you create an object or you pass a function with these arguments, it will be compared to whichever matches and that part of the code will be executed. For function overloading, each overloaded function should have different number of arguments or different types of arguments. You can have int float and then int. That is fine, but you cannot have all the same arguments. And then comes the inline functions. These inline functions are like those one-liner functions. It consists of one line within the function body. Now you would ask, what is the advantage of inline functions? Why is it not like normal functions? What difference does it make? I'll let you know. These are compact function calls and the size of the object code is reduced. The speed of execution of program increases because here the function call is replaced by the function body. The readability of the code also increases since it is just a one-line code. But remember, since the function call is being replaced by the function body, the size of executable file increases and it will need more memory. So inline function, the only disadvantage is it will need more memory space. Another feature of OOPS, data abstraction. The process of hiding the implementation details and exposing only the essential features to the users is called data abstraction. It refers to the representation of essential features of an object as a program object. Abstract class defines an interface but does not provide implementation details. That data abstraction gives you only the key elements and not what is happening behind the data. Last feature of OOPS, constructors and destructors. Constructors are special member functions that are used in classes to initialize the object of a class automatically. And destructors, as in the name, destroy the object after it has been worked with or dealt with. The syntax for constructor here is, remember, the constructor name should be same as the class name. Within the class, after you declare public, you should put the constructor name and then you can give any arguments within the constructor and mention the data. It's called constructor because it constructs the value of data members of the class. Now the rules to write these constructors are, rem- constructor always has the same name as class name. This will help the compiler to identify that it is a constructor. Also, there is no return type to these constructors, not even void. You would ask why. These are just member functions, right? And each member function should have a return type. But except constructors. The constructor is automatically called by the system. There is no program for it to return anything. So a return value would basically be senseless. A constructor should be declared only in the public section of the class. It is invoked automatically when objects are created. It can have default arguments also. It makes implicit calls to the operators new and delete whenever new memory allocation is required. So look at the program here. The class name is test and you can see that function test here is a constructor. It does not have any return type and it is being declared within public. However, here we haven't given any arguments to test. You can if you wish to. Three types of constructors: default, parameterized, and copy. Constructors also, like normal member functions, can be overloaded. The syntax for destructor is, again, it should be the same name as the class name, but you just have to put a tilde symbol before the class name. Constructors is what we have already seen. Parameterized constructors are constructors with parameters or arguments within them. Whenever you create such constructors, you have to also create it during the time of object creation. You should pass those arguments within the object prior. Copy constructor. This is also a parameterized constructor, but here you create an object and give it some initial values, and then you copy the values of that object while creating another object. The constructor can accept a single argument or reference to same class type. The argument must be passed as a constant reference type. Here the syntax is you use the class name, scope resolution operator, class name, and then the class name and pointer. Into all the aspects of OOPS. Let me tell you, why do we prefer OOPS? Advantages of OOPS over earlier programming methods. The programs are modularized based on the principle of classes and objects. The linking code and object allows related objects to share common codes. This will reduce code duplication and code reusability. Data is encapsulated, as we have learned, along with the functions. So, this provides an extra level of security for the data members and member functions by specifying 3 access levels. It is easier to develop complex software, and the complexity can be minimized through inheritance. The concept of data abstraction separates object specification and object implementation. Creation and implementation of OOPS code is easy and reduces software development time. OOPS can communicate with message passing. The disadvantages. Of course, everything have few disadvantages. The disadvantages is it does not have some set standards. The adaptability of flow diagrams and OOP programming using classes and objects is a little complex. Converting real world problems into object oriented models are quite difficult. And the classes are sometimes overly generalized. Use OOPS. You use it in AI and expert systems, simulation and modeling, real time systems, CAD CAM software, object oriented databases, etc. So, what are your takeaways from this session? Number one is object oriented programming is a programming paradigm that uses objects to design applications and computer programs. The OOPS uses several techniques such as inheritance, abstraction, modularity, polymorphism, encapsulation, abstraction, etc. Objects represent data and associate functions as a single unit. Class is a way of grouping objects having similar characteristics. It is a blueprint of classes, of objects. Abstraction. The representation of essential features only and not the details behind it. Encapsulation. The way of combining data and associated functions into a single unit. Inheritance. The capability of class to inherit properties of another class. The class that inherits the properties from another class is known as derived or subclass. The class that provides its properties to subclass is known as base class. Polymorphism, the ability of a function to have same name and multiple forms. The appropriate function is called automatically by the computer depending on the number and type of arguments. Message passing, the processing in data in OOPS is carried out by sending messages to objects. We've looked into each of these concepts with their meanings, definitions, and basic syntaxes. It was a informative and a revision to all of you. Thank you.